Advanced Math Unit 4B review, looking at number 115. F of x equals 3 sine of x. Okay. So when I set this up, I need to create an axis. So this is the sine curve, and when I look at it, hopefully I realize that there's no period change or phase shift, horizontal translation, which is usually the biggest issue. Okay, so really all I have is an amplitude change. Okay, so I still have my regular x-intercepts, which are at 0, pi, and 2 pi. The amplitude is 3, so I go up to 3 and down to 3. There's my curve. 116. 2 cosine x. Okay. Oh, sorry, that equals f of x. Okay. So same thing here. Set up my axis here. So I'm just going to put the ones that I usually put on there. Increments of 2 pi. Okay. So I have a positive amplitude, so I'm still going to start right here. Usually I start at 1 for the parent function, but it has an amplitude of 2, so I'm going to go up 2, and I'm going to go down 2. Right? And these are my x-intercepts. Okay. I'm going to do the best I can to kind of get a little bit of curvature to that. Don't make it look like a V. Alright. And there we go. 117. Okay. So 117 is f of x equals 1 over 4 cosine x. Alright, so same type of question here. Only have a change in amplitude. So same thing, I got my x-intercepts here in the middle at pi over 2 and 3 pi over 2. It's positive, so I still start up here, but I'm only going to go up a fourth, so that's 0.25. So you can see that I'm only going to go down a fourth. So you can see here this is going to really flatten out my curve. Alright, really flatten out my curve. 118. So this is f of x equals 7/2 sine x. So same type of thing here. Okay. So what might help you is just kind of get a decimal on that 7/2, you know, and so if you divide that up, that's 3.5. Okay, so I'm going to actually make this a little bit longer here at the bottom. So there's, okay, and there's pi over 2, pi, 3 pi over 2, and 2 pi. Alright, so the amplitude is basically, this is, I can think of this, you know, as that, right? So I go up, so I still have, let me get my x-intercepts. So here's 3.5's about right there. 1, 2, 3.5's right there. So there's my sine curve. Once again, no change to the period or any kind of a phase shift. Okay, and there you go. All right, jumping to question 124. 124 is f of x equals -2 sine pi x. Okay, so we're going to have a negative amplitude, right? So we're going to go down first, and we have a change in the period. So remember, for formula, the period is equal to 2 pi divided by the number in front of the x. In this case, it's just pi. Okay, so the period is 2. So that's to complete one full cycle. Okay. And remember, we really only want the beginning, the end, and the middle. So if I end at 2, the middle is 1, so it's really not that bad. Okay, so I'm going to say, a half, 1, 3 halves, not pi, just halves, right? And then 2 and 2. Okay, so at halfway, I got to go down 2. Oh, yeah. And then there's my middle, there's my end, and I'm going to be up to here. So in this case, there's my sine curve. Right there. 127 says f of x equals -5 halves cosine x over 4. Okay, so to kind of make that a little easier on myself, to kind of get a feel for what's really going on here, I'm going to rewrite this as -2.5 cosine 1/4 x. The exact same thing. Okay, so I have a negative amplitude, I have a change to the period again. Okay, so I'm going to go ahead and get my axis set up here. So let's do a little work here. So so I have 2 pi. I'm going to find the period over 4, so I multiply that. That's 8 pi. Okay, so it's going to be 8 pi to finish one full cycle of the cosine. So I'm going to spread this out a little bit. So there's pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. We've got to make this a little bit longer. 7 pi and 8 pi. Okay, so I'm going to start here at -2.5 for an amplitude. Okay, so here's 1, 2, here's a half right there, and I'm also going to end right there, and then my middle, I got to go up 2.5. Okay, so I want to find the middle of those. That's my x-intercept. Okay, so round that out a little bit better there. So I kind of dot that till I get the shape I want. Then I'll trace over it. Okay, so I had a period change right here, and I had an amplitude change right there. All right, 129. So now we're looking at f of x equals 5 halves sine x minus pi. Okay, so there's no value in front of the x, so there's no period change, but I do have something added to that value, so this is going to be a horizontal translation or a phase shift. Okay, so setting this up again. Okay, so I'm going to go ahead and set this up as pi, 2 pi, 3 pi, and 4 pi. Okay, so if I had a parent function, I would start here and end here, right? Which would go, basically up 1, down 1. Okay, that'd be my parent function, just kind of that little graph right there. Okay, so what this tells me is I have an amplitude of 2.5. Okay, so I'm going to go up 2.5, down 2.5. But I also have a horizontal translation, right? If you remember, the formula has a minus, so I'm actually going to the right pi. Okay, so what I'm going to do is I'm going to start there, so that means I'm going to end at 3 pi, and I'm going to go up 2.5, right? Because 5 over 2 is 2.5. So basically, I'm going to go 1, 2.5, halfway, 1, 2.5, and so now. So if you look at it, all it did was move me over a pi. I started at pi versus starting at 0. Okay, and I have an amplitude of 2.5. One more for this video. F of x equals 3 cosine x plus pi. Okay, so this gives me a another phase shift, horizontal here. Okay, I'm going to kind of scoot my axis over because that's a plus, so I'm going to move to the left. Okay, so I'll go ahead and do these in pi over 2s. I'm over here on the negative side. Okay. So for cosine, for this one I have an amplitude of 3. Okay. So I'm going to go up 3 and down 3. It's positive, so I'm still going to start up here, but I'm just going to have to scoot over, right? Instead of starting at 0, 0, I'm going to start at negative pi. So I'm going to start there, and there's no change to the period, so it's still 2 pi. So there's a pi, that's 1 pi, there's 2 pi. Okay, there's my halfway point. These are my in the middle of those. So 1 full period of cosine would look something like that.